In section 7.9, we're going to talk about solving more complicated radical equations. But before we talk about the more complicated ones, let's review how to solve regular radical equations. So here are the steps. Isolate the radical, square both sides, and then solve for x. And then check your solution just to make sure that they're not extraneous. In our previous section, we would get a problem like this, okay? And this is probably the most complicated that it would get. In this section, however, we're going to have something like this. Notice that the radicals don't match. This is the square root of y minus 3, and this is the square root of y. So since these radicals don't match, we can't combine them. We cannot combine them like we did in the previous section. So we have to figure out, well, how do we deal with them? So here are your new steps for solving complicated radical equations where radicals don't match. Okay, so step 1, isolate the more complicated radical. Step 2, square both sides. And then step 3, isolate the remaining radical. And then step 4, square both sides again. And then step 5, solve for x. So when you square both sides, before when we would square something like this, the square root of x minus 3 squared, we would just get x minus 3. And this is important because whenever you use the box method, you are going to get things like the square root of x minus 3 times the square root of x minus 3. And in your box, you're going to put x minus 3. The radical will cancel itself out. What about the square root of x plus 4 squared? So for this one, you are going to want to use the box method or the FOIL method because the square root of x plus 4 squared is really saying the square root of x plus 4 times the square root of x plus 4. So notice this is the top part of your box and this is the side of your box. So now you can use your box method to go ahead and multiply. So the square root of x times the square root of x. Remember the square roots cancel, leaving you just x. And then you get 4 square roots of x plus 4 square roots of x, which is 8 square roots of x. And then 4 times 4 is 16. Let's look at this one. The square root of x minus 2 plus 5 squared. Again, that squared means that we're going to multiply the square root of x minus 2 plus 5 times itself, the square root of x minus 2 plus 5. So because we're squaring it, we're multiplying by it itself, we're going to have to use the box method. So in the top left hand box, we have to multiply the square root of x minus 2 times the square root of x minus 2. And when we do that, the square roots cancel out, leaving us just x minus 2. Okay, and then in the top right hand box, we get 5 times the square root of x minus 2, which is 5 square roots of x minus 2. And then in the bottom left hand box, we get 5 times the square root of x minus 2 again. So again, we have 5 square roots of x minus 2. And then in the last bottom right-hand corner of your box, you have 5 times 5, which is 25. So when you combine like terms, 5 square roots of x minus 2 plus 5 square roots of x minus 2, you get 10 square roots of x minus 2. And then, of course, you have the 25. You can do some more combining because you have this minus 2 here and this 25 here. So minus 2 plus 25 leaves you with 23. All right, so you go ahead and try this one. Again, remember to use the box method and try to figure out what the correct answer is. All right, you should have gotten option 2, x minus 6 square roots of x plus 2 plus 11. All right, so now that we've gotten really, really good at squaring complicated things, now we're going to actually solve. So this whole time, we actually have not even solved anything. We were just practicing using the box method. So now we're going to do an actual example of solving a radical equation. So here's our first example of solving a radical equation. We have the square root of x minus 4 equals the square root of x minus 8. So the question is, which radical is more complicated? Well, the square root of x minus 8 is more complicated because it has two terms in it. So, is it isolated? Yes, it is isolated, which means that we can move on to the next step. Let's look at this problem. The square root of 2x plus 5 equals the square root of 2x plus 38 minus 3. So the first thing we want to do is, which one is the more complicated radical? I'm going to say 2x plus the square root of 2x plus 38 because 38 is bigger than 5. So I want to isolate this radical. In order to isolate the radical, I have to add 3 to both sides. And when I add 3 to both sides, I'm left with this step right here. The square root of 2x plus 5 plus 3 equals the square root of 2x plus 38. Now I'm ready to square both sides. And when I square both sides, I'm going to have to put this left hand, the square root of 2x plus 5 plus 3, I am going to, in order to square that, I'm going to have to use the box method. And so when I use the box method, I get 2x plus 5 plus 3 square root of 2x plus 5 plus 3 square root of 2x plus 5 plus 9. And then when I square my right-hand side, the radical cancels, leaving me just 2x plus 38. So now I'm going to go ahead and try to isolate this radical, right? In order to isolate this radical, the square root of 2x plus 5, I'm going to subtract 2x from both sides. And when I subtract 2x from both sides, oh, it completely cancels out. There's no more 2x's on either side. So I'm left with 5 plus 3 square root of 2x plus 5 plus 3 square root of 2x plus 5 plus 9 equals 38. So now I'm going to combine like terms. So 5 plus 9 is 14. And then 3 square root of 2x plus 5 plus 3 square root of 2x plus 5 equals 6 square root of 2x plus 5 equals 38, right? So now I'm almost done isolating this radical. I'm going to subtract 14 from both sides, leaving me 6 square root of 2x plus 5 equals 24. So now I'm going to divide both sides by 6, leaving me the square root of 2x plus 5 equals 4. Now I'm going to square both sides, which leaves me 2x plus 5 equals 16. Now I just have to solve for x. I subtract 5 from both sides, which leaves me 2x equals 11. And then I'll divide both sides by 2, which means that x is equal to 11 over 2. All right, let's do this problem. We have the square root of x plus 3 equals the square root of x minus 13 plus 4. So I'm going to say that the more complicated radical is the square root of x minus 13, just because 13 is bigger than 3 and it's a negative, so it looks more complicated. So what I want to do is I want to isolate that radical because it's the more complicated one. So I have to get rid of this plus 4. So I'm going to subtract 4 from both sides, leaving me with the square root of x plus 3 minus 4 equals the square root of x minus 13. Now I'm ready to square both sides. And when I square both sides, I am going to have to use the box method on the left-hand side. I will have to use the box method on the left-hand side. So the square root of x plus 3 times the square root of x plus 3 is just x plus 3. And then negative 4 times the square root of x plus 3 is negative 4 square root of x plus 3. And then negative 4 times the square root of x plus 3, square root of x plus 3 is negative 4 square root of x plus 3. And then negative 4 times negative 4 is 16. And then on the right-hand side, when I square the square root of x minus 13, the square and the square root cancel, leaving me just x minus 13. So now I'm ready to isolate this variable. So now I want to move everything to the right-hand side. So the first thing I'm going to do is I'm going to subtract both sides by x. And when I subtract both sides by x, it just so happens that the x disappears altogether, leaving me 3 minus 4 square roots of x plus 3 minus 4 square roots of x plus 3 plus 16 equals negative 13. Ooh. So now I need to combine like terms. 3 plus 16 is 19. Negative 4 square roots of x plus 3 minus 4 square roots of x plus 3 is minus 8 square roots of x plus 3 equals negative 13 still. So now I'm almost done solving or isolating the radical. Now I need to subtract 19 from both sides. So negative 13 minus 19 gives me negative 32. So now I have negative 8 square root of x plus 3 equals negative 32. You might be a little concerned that this is negative 32, but don't say no solution quite yet, because we have not finished isolating the radical. You can't say that there's no solution until the radical is completely isolated, and it's not yet. So we're going to divide both sides by negative 8. And when we do, we get positive 4, because negative 32 divided by negative 8 is positive 4. So now I've got the square root of x plus 3 equals 4. Now I can legally square both sides, giving me x plus 3 equals 16, which means that x is equal to 13. All right, let's do this problem. So this problem, your radical is already isolated, which is nice. It just means that you have to square both sides. But when you square both sides, you are going to have to put the left-hand side, 2x plus 4, into your box method. You have 2x plus 4 on the top and 2x plus 4 on the side. And when you do that, 2x times 2x is 4x squared, and then 4 times 2x is 8x, and then 4 times 2x is 8x, and then 4 times 4 is 16. Equals, when you square the right-hand side, you're left with what's inside the radical, which is 5x squared plus 21x plus 10. So at this point, at this moment in time, I don't have any more radicals, and I need to solve for x. I notice that the highest degree that I have is squared, which means that this is possibly a quadratic. So I want to get everything set equal to 0. So in order to get everything set equal to 0, the first thing I'm going to do is I'm going to subtract 4x squared from both sides. And when I do that, I'm left with 8x plus 16 equals x squared plus 21x plus 10. So now I'm going to combine like terms. So 8x plus 8x equals 16x. So that's this step here. And now I'm going to continue trying to make the left-hand side equal to 0. So I'm going to subtract 16x from both sides. So I'm left with 16 equals x squared, but 21x minus 16x leaves me 5x plus 10. So the next thing I need to do to get the left-hand side to be 0 is subtract 16, right? So I have 0 equals x squared plus 5x, and then 10 minus 16 is negative 6. Okay, so now I have 0 equals x squared plus 5x minus 6. At this point in time, we have a quadratic, and it's set equal to 0. So you have a couple of options. You can either use the graphing method, the factoring method, or the quadratic formula. Any of those three options will help you solve for x. I'm going to use the factoring method. So I'm going to factor x squared plus 5x minus 6. So that means that I know that I'm going to have x and x, but I need two numbers that multiply together to get negative 6, but add up to positive 5. So that would be 6 and negative 1. Okay, so here are my two factors, x plus 6, x minus 1. You can also use the reverse box method to help you figure out what those two factors are going to be. So now I have 0 equals x plus 6 times x minus 1. Well, the 0 multiplication property says that if 0 is equal to two numbers multiplied together, that one of them is equal to 0. So either x plus 6 is equal to 0 or x minus 1 is equal to 0. So now we solve for x, and so either x is equal to negative 6 or x equals 1. So either of these could be our answer. However, we need to check our solution. It just so happens that this radical is already solved for, so all I need to do is make sure that the left-hand side never becomes negative. If x is equal to negative 6, well, 2 times negative 6 is negative 12, and then negative 12 plus 4 is negative 8, which means that I have a radical equal to a negative number. That can't be it. So x equals negative 6 cannot be a solution. Cannot be a solution. It means that the only solution is x equals 1, because then it's equal to a positive number. So x equals 1 is actually the only correct solution. All right, let's do another problem just like the one before. So again, we need to square both sides to start with. And so when we square the left-hand side, we use the box method, which gives us 9x squared plus 12x plus 12x plus 16. And then when we square the right-hand side, we're left with 10x squared plus 29x plus 22. So I have no more radicals, which means that it looks like x squared is the highest term, which means it's a quadratic, which means that I want to get it set equal to 0. So I'm going to subtract 9x squared from both sides, leaving me 12x plus 12x plus 16 equals x squared plus 29x plus 22. I'll combine like terms, and that 12x plus 12x will become 24x. And then I'm going to subtract 24x from both sides, leaving me 16 equals x squared plus 5x plus 22. And then I'm going to subtract 16 from both sides, leaving me 0 equals x squared plus 5x plus 6. And then in order to solve this quadratic, I'm going to factor it using the reverse box method. So I need two numbers that multiply together to get 6, but add up to 5. That would be 3 and 2. So my factors are x plus 3 and x plus 2. So according to the 0 multiplication property, either x plus 3 equals 0 or x plus 2 equals 0, which means x equals negative 3 or x equals negative 2. However, if x equals negative 3, I'll get a negative number set equal to a radical. So it can't be x equals negative 3. But if I get x equals negative 2, I'll get another negative number, which means both of these answers are extraneous. Neither of them work. No solution. All right, let's see if you can figure this one out. Okay, you should have gotten option 1 because you're trying to solve for f. The first thing you should have done was square both sides, leaving you s squared equals 30 times f times d. And to solve for f, you're going to divide each side by 30d to cancel out the 30d on the right-hand side, leaving you just f. So you have s squared divided by 30d equals f, which is the same thing as saying f equals s squared divided by 30d, which is option number 1. All right, your turn. You're going to do 2 through 6 evens on 7.9.